Okay, example 3, set up but do not evaluate the integral for arc length. No big deal there, so let's go ahead and find dx dt. So the derivative of e to the t is e to the t. Derivative of 2 is 0, so that one's done. dy dt is just 2. So my integral, they give me the times, which makes this easy, becomes the integral from lower time to upper time of the square root of dx dt squared plus dy dt squared dt. Only reason I could see people missing this is messing up the simplification. This would be e to the 2t, power to power means multiply, plus 4 dt. And then you'd be done there. All right, they get a little messier. What makes these harder? It's really limited by is the derivative difficult or not. This one is a little bit of a hot mess. So looking at the derivative, so dx dt, that's x. So dx dt is a product rule. So this one's a little bit of work. So the derivative of the first would be negative e to the negative t times the second, which is cosine of t. And then it's plus, now the derivative of the second, derivative of cosine is negative sign, so that winds up making it a minus e to the negative t sine t. What you can do with that is you can go ahead and factor that and take out negative e to the negative t, and then it becomes cosine of t minus sine of t. So there's your dx dt, same thing for dy dt. So once again, it's a product rule. And the derivative of the second times the first. We could factor this as well. So it's just a plain e to the negative t this time. So now I can write my integral. So it's going to be the integral 0 pi over 2, big old square root, dx dt. Let's see, sorry. Squared plus, and then dy dt. Squared dt. Evaluating this becomes a chore. You would at least need to be able to simplify this. Okay, the key to simplifying is making sure that the square gets attributed to the negative e to the negative t, as well as the cosine minus the sine and the cosine plus the sine. But we're going to stop there. All right, last two. So this one, when we read it, it's describing a figure. You honestly don't need to know what the figure looks like. Circle rolls around the circumference of a larger circle. Figure traced out is called an epicycloid, given by this function. So it's find the distance traveled by one complete trip about the larger circle. What that means is my domain for time is 0 to 2 pi. If you wanted to picture what this thing looks like, here it is. So in red, you have a circle of radius 4, and I'm kind of rolling a circle. Imagine if you rolled a penny around another penny, and I'm tracing the edge. That's kind of what the picture I would look like. So the arc length it wants is this blue curve. Now, there are different ways to do this. Some of you see symmetry very well. So you could see, hey, maybe I could just do 0 to pi over 2 and then multiply it by 4, or I could do 0 to 2 pi. You could do 0 to pi and double it. There's a lot of different options. But my integral is just going to be 0 to 2 pi of the square root of x prime squared plus y prime squared dt. So really, it just becomes, hey, can you take the derivative of x and the derivative of y? And if you can, then this isn't so bad. Now, evaluating it would be a little bit of a chore, but we're just in the setup business here. So the derivative of x I'm going to pause and let you make sure you can do that on your own. And then the derivative of y. And make sure, again, you can do this on your own. There. This does simplify. It's possible to eliminate it down. I'm not going to go through the process of doing that right now. Me not being there wouldn't be very worth your while. If you're interested in it, there's a picture if you want to pause and check it out. But I don't think many people will be, so don't worry about it. I'm not going to ask you to do that. All right, last thing, and then we're done. And I do like this. Pretty cool. So it says verify the equation of circumference of a circle. So if you've ever wondered how is pi r squared and 2 pi r, how are they related? Verify the equation of a circumference of a circle using a general parametric. So general meaning not a specific circle, but a general circle. So A being my radius here. So x equals a cosine theta, y equals a sine theta. So x prime. So a is just a number, remember, would be negative a cosine theta, and then y prime is going to be positive a cosine theta. So for the integral here, I do the integral from 0 to 2 pi square root negative a cosine theta quantity squared plus positive a cosine theta quantity squared d theta. Pause and see if you can simplify this on your own. This is going to become a squared cosine squared theta plus a squared cosine squared theta again. Wait a second, sorry. I didn't take the derivative, so that should be a sine theta, and this should be a sine theta, and this should be a sine theta. There we go. All right, from here, a squared can be factored out. A squared is just a coefficient, it's a number. So when I take a squared out, the key is you got to not forget to take the square root of it. So out front of this whole thing, I can take the square root of a squared, which is an a, integral from 0 to 2 pi of the square root of sine squared theta plus cosine squared theta. Hopefully we recognize what that is. That's 1, so square root of 1 is just 1. So this becomes a integral from 0 to 2 pi of 1 d theta. Okay, so the integral of 1 is just theta, so this is a times theta from 2 pi to 0, which becomes 2 pi a minus 0. So my circumference equals 2 pi a. And what we said from the beginning was that a equals the radius. So what we found is circumference equals 2 pi r. Boom.